Well, well, what has the cat dragged in today? Well, this one's a bit of a ballsy tutorial. No, I'm not going to apologize for that. But in all seriousness, we're continuing on with our Plinko tutorial series and taking a look at how to move the ball and release it. So let's get started. Now, of course, as the project stands now, if I hit the run button, the ball will drop, it'll bounce a little bit on the peg, and then come to a complete standstill. I have no control over moving it left or right, obviously, because we haven't told the ball to move. That is one thing you should always keep in mind for game development, is that computers are dumb. They are phenomenally stupid, and they will do precisely what you have told them to do. No more, no less. So let's tell this to do something. So I'm going to add on a flow machine, and I'm going to set this to embedded. I call it ball control, and I'm going to go into edit graph here. Now, something I didn't do in the last video, but I have since come to love because I finally noticed the full screen button. There we go. We have full screen, and it's easy to toggle back and forth. Now, of course, my preferred workflow is still to have this window off on my other monitor, full screen that way, along with other windows. But as I've said before, that doesn't really work too good when it comes to video tutorials. Now, what do I need to do here? You always want to try to think this out, and ideally use a really complicated piece of technology called paper. That's right. Paper's good because you can draw out your logic on a piece of paper and get a good idea for the flow of things before you get started. But in this case, I already know exactly what we need to do, so let's get started on it. First, I'm not going to need a start event. There's nothing that I need to do to initialize this on load. So I'm just going to go ahead and get rid of that to keep things from getting cluttered. Now, what am I going to need to do? I'm going to need to move it. And moving, I'm going to do that in a super unit. I always want to look for ways of cleaning up our flow graphs and thinking in terms of logical chunks of operation and then gluing those chunks together. Because thinking that way will prepare you for more complex flows that use embedded macros, which is something we'll get to in a different tutorial. So I'm going to drop in a super unit, which I shall call movement. So I know I'm going to need a super unit for movement. And I'm also, the whole release process of switching on kinematics, of setting the force and the torque and so on and so forth, that's a nice logical chunk of operation as well. So I'm going to toss in a super unit for that just right off the bat. There we go. And then just so I can make sure my flow logic is working, I like to keep things as functional as possible at all times. So I'm going to dive real quick into these two super units because I know I'm going to need a start and a finish on both of these outputs. And I'm just going to go ahead and link them together. Hop back up to the ball here, go into super unit, and I'm going to do the same thing. I'm going to put in a start and a finish. Link them together. So that way I can just chain things together. Now, like I said, computers will do precisely what you tell them to do. No more, no less. And so I need to think a little bit. When I'm controlling this ball and I'm moving it left and right, do I want to have the ability to move it after it's been dropped? And the answer to that is no. I do not want to have any control over it after it has been dropped. Nor do I want to be able to release it again and re-add in that random force and random torque. But were I to just simply do this, every update loop, handle my movement, and then detect whether or not and handle my ball release, I'm going to be able to control it midair. It's not what I want. So I need to add in a little bit of logic to stop this. So I'm going to come over here and at the graph level, I am going to add in a Boolean variable to keep track of whether or not the ball is at the top of the screen. And if it is not at the top of the screen, then I don't want the update loop to be able to do anything. I don't want to be able to move it. I don't want to be able to release it. So I am going to immediately do a branch and only if it's true am I going to handle doing my movement. I don't need to put anything on the false because there's nothing that I need to do. If the answer is false, if is top is not true, then the flow just ends. There's nothing left for the flow to do, which is exactly what I want. So there's nothing I need to put there. So we are at the top. I've handled my movement. Now, how do I know when to do my release? I could put that logic into the super unit, but I would prefer to actually have that logic out here. Should I call the ball release super unit? So that is the logic that I'm going to place out here. And to that end, I'm going to, again, use the input system, but this time I'm going to check for buttons. Last time we used axes. So let's go back into our project setting, look at our input manager. Last time I was using the horizontal and vertical, and I was using the input.getAxis. You can also read all of these as buttons as well, in which case you don't get a range of -1 to 1. You just simply get, is the button down, yes or no? So it really depends on what you are looking for. For something like firing or jumping or some sort of action, you probably only care about, is it down, is it up? As opposed to something like vertical or horizontal, especially on a controller where you have analog input instead of the digital input on or off of a keyboard, the scale matters here. In this case, I only care about on or off. So I am going to do another branch. And the true-false version of this is going to be, I'm going to get button. And I'm going to get button down. The difference here is, again, as explained in the previous video, is how many times per frame does this happen. Get button happens every frame. Get button up happens the very first frame the button is released. Get button down happens the very first frame the button is pressed. I want to get button down because I don't want the player just to hold down the left mouse button and have the ball auto launch. It's a simple thing. It's probably not anything that's actually going to really happen all that much. Now, there's two ways we can link this up. Notice I've got it down here. We could link it like this. Or we could link it like this. Either way works. The key thing is paying attention to whether or not our wires are highlighted. Notice if I disconnect that wire by right-clicking, this purple wire is dimmed, indicating that it's not being activated. As soon as I relink the branch up to the sequence, that wire gets lit up, indicating that yes, this connection is going to be used. So I'm going to get whether or not the button is down. Now, which button? I want fire 1, and I'm going to double check because I am paranoid. Yes, okay, the F is capitalized. Remember, these are strings, so capitalization is important. Now, again, if this is true, well, actually there's a couple of things I need to do. First, I want to turn off is top. So I am going to come through here, and I am going to set my graph variable is top. And I'm going to set that to a bool literal, unchecked for false. And then I'm going to proceed on to the ball release super unit. Again, there's nothing that I need to put out for false here because, well, if I didn't push the button, then the flow's done. Work over, don't need to worry about it. And this is enough to test. This is why I like to keep things as functional as I can. Because the smaller the unit that you can test, the easier it is to figure out where your mistake is. So I'm going to turn this off of full screen. I'm going to drag my flow graph down here so I can see the pulses. I'm going to make sure that my game is not maximize on play. Hit the play button. Now what I should see yes, a reminder that we forgot to put in a very, very important setting on the ball. The ball should not fall as soon as the game is started, as it just did. Instead, I want to quasi turn off the physics. And the easiest way to do that is to not disable the rigid body, but rather mark it as kinematic. If you mark a physics component as kinematic, you are telling it, yes, it's a moving object. Yes, it's going to collide with other physics objects, but the physics system has no control over it. So by marking it as kinematic, it stays up in the air. And now looking at my pulses, I can see that, yes, these are the pulses that I would expect. It is at the top, so I would expect my pulse to go through movement. Now, as soon as I click in here, I should see a pulse go through to super release, and then the pulses should stop right here. So click. There we go. We saw the pulse flow through, and now the pulses are stopping back here because it's no longer on top according to my logic. So that is working just fine. Let's do the physics first, and then we'll break the movement out into a separate video, actually. Because this is getting a little bit long in the tooth, and I like to try to keep these things sub 30 minutes. So let's go into our release and think about what is it that we need to do. There are 3 primary tasks. We need to turn kinematic off, so that way the simulation can control the ball's movement. We need to add a random amount of force, so it doesn't drop the same way. And we need to add a random torque, so it will randomly spin and bounce in different ways. First things first, let's turn off kinematic. So we have a rigid body is kinematic. I am self refers to the game object that I am on, which is correct, so I don't need to do anything there, and I'm turning it off, so I do not want that checked. So there we go. Kinematics turned off. Now I need to add a random amount of force. So if I stretch this out, and I type in add force, notice I've got a couple of different variations here. I'm going to take the add force XYZ mode for two very important reasons. The biggest reason is I want this mode option. Because as you can see here, there's 4 different types of forces that we can add to an object. These are important. I'm not going to get into the details in this video. And to be quite honest, if you are really wanting like good top tier physics in your game, yeah, the Unity physics system's a little special, if I'm to be honest. So you probably want to be looking for different solutions, maybe using the new Havoc solution or something like that. But the key thing here is understanding what type of force are you applying. Is it a constant acceleration? Or is this a quick impulse of force? Because these have different calculations on how the force is actually applied to the object. This is an impulse. We are in a single frame adding this force in. So I want the mode to be impulse. And I'm only going to be adding the force to the X component, so left, right. So that's why I wanted the XYZ component version of add force, so that way it's easiest to get to here. Now, how do I add something random in? Well, thankfully, Unity does have a series of random functions. We have random range for floats, and we have random range for integers. I'm going to want a float here. The rigid body is going to be expecting a float, so I might as well give it what it expects. Now I'm going to set it to a range of -25 to 25. This is a bit much. You could experiment around with these values, tweak them, figure out what's a good value to use. This makes sure that the random force is almost always very noticeable, which can make it a little bit hard to control sometimes. And that's why I'm choosing such a broad range. It makes it noticeable. Let's just tighten things up here a little bit. And then the other thing that we need to do on our release is we need to add torque that will spin the ball. Again, I'm going to use the XYZ mode version because this is an impulse. We're at a single impulse in a single frame. And again, I'm going to be using random range. I'm just going to Control-C, Control-V that. Link it up to X. And use the same range, -25 to 25. And then I'm going to link that into finish. That's it. Now we have a unit that we can test. So I'm going to get that out of full screen. I don't really need to see the pulses on this one, but I'm still going to drag it down here so I can watch it anyways. Now I shouldn't see any impulses in this super unit until I click in the screen, and then I should see the impulse go through the whole range here. Yep, there we go. Obviously that needs to be a trigger. And there we go. It is moving differently every time we hit play. And we can look at our values too. So like, oh, hello. You went flying way the heck off to the side there. That was actually a bit unusual. And there we go. We now have our randomized release done. The next part is going to be to handle the left and right movement on the ball, but that one's a bit more involved, so let's hold that off for the next video. As always, if you've enjoyed the content, thumbs up would be appreciated, and if not, that's understandable, and the thumbs down button is right next to it. See you in the next video.